So in this video, we're going to continue looking at the loci of complex numbers. So we saw in a previous video that when you have the magnitude of a complex number z, and this is equal to a constant, when this creates a circle. In this video, we're going to look at loci of this form. And what this means is that the distance between a general complex number z and a fixed complex number, let's say z1, the distance between these two is exactly the same as the distance between the same general complex number and a different fixed complex number. Now, this z, because it is general, this means it can move, and we're going to look at the locus of the points where it can move that makes this statement true. Okay, so if we begin by plotting Z1 on our Argand diagram, let's say we plot it over here. So this is the fixed point, and this now cannot move. And we plot Z2. Let's say we plot this over here. And again, Z2 cannot move. We want to identify the locus of the points where the distance between Z and each of these two are equal. So if we begin by rewriting each of these in a more convenient form, all I'm going to do is move this negative z1 to the front. So negative z1 plus z. Well, I can plot part of this on our Argand diagram. If we look at this at negative z1, well, positive z1 comes from the origin, so negative z1 will take us back to the origin. And we can do exactly the same thing with this statement. We'll have negative z2 plus z. And this negative z2 I can plot, and it takes us back to the origin. So with z, this z term must originate from the origin, and it would come from the origin and be at a point which is equidistant between z1 and z2. So for instance, it could come here, and it would come from the origin to this point, and this could be z. So can you see at this point, the distance between z2 and z is exactly the same as the distance between z1 and z. So this statement holds true. But it could also have been here, or here, or here. And actually, these points join together to make a line. And can you see that at any point on this line, the distance from Z1 is exactly the same as the distance from Z2. And this would be isosceles. It could also be isosceles at this point. So what this does in this line, it shows us all the points where Z could be. It's the locus of Z. So because it bisects Z1 and Z2, we know this is the perpendicular bisector, and this describes the locus of the complex number Z. Okay?